Okay guys, here's page 2. So it says find the perimeter. Perimeter means the sum of the outside. So what is the whole length of this outside? So since I have a rectangle here, I know the top and the bottom are the same. And the two sides are the same. A lot of you have been saying, since this is the same, I can just multiply everything by 2 and saying that this is 2x squared minus 10. And then adding it to the other one, which is perfectly fine. So this is going to be 6x plus 4. So if you did it that way, you're perfectly fine. If you add all 4 of these up, you're perfectly fine. Now we need to add these two together. Or we can only add like terms. And this is where I told you be careful if you stack, because these two are not like terms. This one has an x squared and this one has an x. So I can't actually add those two together. So what I'm going to do is I'm going to rewrite it real fast. I'm going to say 2x squared plus 0x's minus 10. What this is it works as like a placeholder so that when I line this other one up underneath it, I have an x column. So now I'm going to say a negative 10 and a positive 4. Opposites subtract. I've got 6x, because 6 plus 0 is 6. This would be 2x squared. Number 7. Anytime that I have something like this, it means multiply by itself. So I want to make sure that I multiply this entire thing by itself. So what I'm going to start by doing is rewriting it as 4x plus 2 times 4x plus 2. Now when I do this, I have rewritten it so that I don't make a very common mistake. An easy mistake to make is to square this one and say 16x squared plus 4. And what it's going to do is it's going to accidentally leave out our middle term. So I'm going to do the first one, and I get 16x squared. And the second one, plus 8x, which is what I would have missed doing the other. Now I'm going to do the second term, and I'm using distribution this time. I will use a stacking method in another problem later on. So I multiplied. Remember, there are 2 terms here and 2 terms here. So that means that after I get done multiplying, I should have 4 terms. 1, 2, 3, 4. So now that I know that, I can combine my like terms. And I'm finished. Number 8 is one of our nice word problems. If there are 12 inches in a foot and 3.28 feet in a meter, a person who's 75 inches tall is how many meters tall? So we're going to start with what we know about the person. So what I'm starting with is 75 inches. And I always make my picket fence or my chart. Remember, if I had the word per, I would put something in the bottom, but there's no word per here. It just says there's 75 inches. Now I'm going to look back at what they told me. It says there's 12 inches in a foot, so I know I'm using 12 inches equals 1 foot. And they said 3.28 feet are equal to 1 meter. So once again, I've read this word problem 2 times, and I have now brought all the information out, and I don't have to worry about it anymore. I do need to know what unit I'm ending with, so I went back over here. Let's see how many meters tall. So now I know the unit I'm ending with is meters. Since it's a word problem, I don't have to decide what I'm going to use. They actually told me I'm using these 2 things. That's the nice thing about word problems. It's the only thing that makes them easier. Now we need to know what to cancel out to get there. So I've got inches. I need to figure out which one of these has inches so I can cancel out. Looks like it's the top one. Inches goes on bottom, so it's opposite. What it's equal to goes on top. Inches are gone. Now I need to get rid of feet. The other one has feet. Put them on bottom so they cancel again. And now the only unit left is meters. Meters is what I was looking for. So all I gotta do is multiply. The top is 75. Plug the bottom in the calculator. 12. Try that one more time. 12 times 3.28. 39.36. Now I'm going to divide that. 75 divided by 39.36. So they are 1.9 meters tall. Okay, so number 9. Which of these support the claim that a rational and an irrational have the product of an irrational? So a couple of things here. I need the product, which means I need to multiply. And the two things I multiply need to be rational and irrational with an answer that is irrational. So we're proving something true. So all I got to do is look for an answer that has all of those things. So the first one, the square root of 2, is irrational. Square root of 2 is still irrational. And the answer is rational. This is irrational because it's a square root and it's not a perfect square. So it's not 4, 9, 16, any of those perfect squares that reduce. So an irrational times irrational is not what we were looking for. We were looking for a rational times an irrational. So A is not correct. B is an irrational because that's pi times an irrational because that's pi equals an irrational because it still has pi. And we're not looking for two irrationals, just one. So that's not right. C, 1/2 is rational because all fractions are rational. 9 is a whole number, making it also rational. And then this is also rational. So we have a rational times a rational equals a rational, which is always true, but not what we were looking for. And then finally D, because we should always check even though we've knocked out all the other answers. We've got an irrational multiplied by a whole number, so it's rational, is equal to something with a square root, which is irrational, which is exactly what we're looking for. And rational times an irrational is equal to an irrational. So D is our answer there. Number 10 says, which of the following are not rational? Choose all that apply. So we're going to have to simplify some of these to check and see. Some of them we can just look at. I'm going to start with section A, and we know the square root of 64, so this is one that we can simplify and say this is 8 minus 8, which is 0, and that is a rational number. Not rational is going to be the same as irrational, so this is definitely rational. B is a string of decimals. They do not appear to repeat at all, and they do not terminate. They got this dot, 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 or ellipses that goes on forever. So that is going to be an irrational number. C is one we're going to have to simplify. So I'm going to go ahead and distribute my minus sign here. I'm going to say that is 8 plus the square root of 3 minus 4 minus the square root of 3. Now, I'm going to do my like terms. So 8 minus 4 is 4. And the square root of 3 and negative square root of 3 are opposites, which makes them cancel out. My answer is 4, which is a whole number. So C is actually a rational number, or a rational expression. D has a pi. Anything multiplied by pi or added to pi is not going to cancel out. So D has to be irrational or not rational. F, I've got a square and a square root. These two are opposites, which makes them cancel out. So the answer there is 19, which is a rational number. G, I cannot simplify because this one has a square root of 2, and this one's a whole number. And that is not rational or irrational. So the answers to 10 are B, D, and G. Number 11. If there is a 1.61 kilometers in a mile, how fast is someone traveling? 42 miles per hour going in kilometers per minute. So first off, let's highlight what we need to know. we need to know that 1.61 kilometers is equal to 1 mile. And we know that we are starting with 42 miles per hour. And our answer is kilometers per minute. So we're going to start by making our table. This one does have the word per, so I know I'm going to have a top and a bottom. That's 42 miles on top of 1 hour, because it says 42 miles per hour. So 42 miles goes on top, per means I'm moving to the bottom, 1 hour. I'm going to cancel out miles to get kilometers. I'm going to cancel out hours to get minutes. So it's your choice which one to do first. Let's go ahead and do the easy one and get rid of those hours, because everybody knows how to change from hours to minutes. There are 60 minutes in 1 hour. So I'm going to put 1 hour on top so I can cancel those out. And that is equal to 60 minutes. A lot of you like doing this and checking it off when we get what we want. So what we're going to do is we write what our answer was, and once we get what we want the answer to be in, we just put a check beside it, so the bottom is done. Now we've got to get the top, so I'm going to use this conversion they gave me. It said 1.61 kilometers is equal to 1 mile. Mile has to go on bottom because mile was on top. Miles cancel. On top I have kilometers now. So I'm done on top, done on bottom. Once I've checked that off, all I gotta do is put in the calculator. So I multiply the top. There we go. So I multiply the top, 42 times 1.61, 67.62. And the bottom is just 60. You can divide that. Divided by 60. So, if we are going 42 miles per hour, we are going 1.127 kilometers per minute. And then the last one on this sheet is the easiest one of the whole test. It says match each with its appropriate unit of measurement. So what would be appropriate to measure this by? It would make sense to measure a pencil in centimeters. Feet would be too big. Meters would be too big. The length of a wall, length of the hallway, we could either measure that in feet or in meters. Either one of those would make sense. And the width of a doghouse is pretty small but not too big. We can measure that in feet, or we could also measure that in meters. So those would be my matching things there.